Alright, I'm sorry for the shakiness of this video, but we're going to do our best so that you can see me work through these problems. So the first one says property blank. Use slope to determine whether the given vertices form a parallelogram. So which one of those properties, 1 through 6, involved slope? Property 1. So I'm going to put a 1 in that blank. The next step is going to be to plot those points. So I'm going to plot A through D. Plot -2, -1, and label it A. -1, 3, label it B. 4, 3, label it C. And 3, -1, label it D. And then I'm going to connect my points to form my parallelogram. Property 1 says that opposite sides are parallel. So I need to show that AB is parallel to CD, and I need to show that BC is parallel to AD. So I need to show this is parallel to this, and I need to show that this is parallel to this. So in order to do that, I need to calculate the slope. So let's calculate this one first over here. So let's do AB here. AB, 3 minus -1, y2 minus y1 over x2 minus x1. 3 minus -1 is 3 plus 1 over -1 minus -2 is -1 plus 2. So I get a slope of 4. Let's do CD. CD, I have y2 minus y1. So I have -1 minus 3 over x2 minus x1. So over 3 minus 4. I get -4 over -1, which is the same thing as 4. Because both slopes are 4, we know that this is true. Now we need to do BC and later AD. So let's do BC. BC, I've got 3 minus 3 over 4 minus -1. So I have 0 over 5, which is the same thing as 0. I need to make sure that that's parallel to AD. All right, so AD has -1 minus -1 over 3 minus -2, which is 0 over 5, which again is 0. So since both of my slopes of my opposite sides were equal, I know that that does in fact make a parallelogram. So I put that it is a parallelogram by writing that statement there. All right, the second example is a little harder. All right, which one of these properties looked like that with only one diagonal picture? If you say property 6, you are correct. All right, it kind of looks similar to this drawing up here. So these are going to be the same. Property 6, which says that the diagonals form congruent triangles. So I want you to imagine that I have this triangle here, and I can rotate it to make this triangle over here. All right, which means that this angle is congruent to this angle, which means that this angle is 52 degrees. Now, earlier, if you were paying attention during the notes, I said that the angles of a triangle have to add up to what? All my angles have to add up to 180. So the little question mark, 60 and 52 have to add to 180. Which means that I really, when I solve for this question mark, I'm going to subtract 60 and I'm going to subtract 52. So in other words, I'm going to subtract my 112, right? And I get that my question mark equals 68 degrees. Now, looking at the other one, all right, again, I have two congruent triangles. So I need to form them by rotating the triangles onto each other. So that means that this degree is the same as this degree, 62. Now, again, the angles add up to 180. So I have 62 degrees plus 55 degrees plus my question mark should add up to 180. So I'm going to add all those up. I should get 117. Correct me if I'm wrong. 117 plus my question mark equals 180. In solving, I subtract 117 over here, and I get 63 degrees. Okay. This top example on the next page involves two angles that are next to each other. What property did we talk about that had two angles being next to each other? Property 4. We said that the two angles that are next to each other are what? They should be supplementary, right? We said there's sup. So if you look back at your picture, there's that two angles and it says sup. So that means that 70 plus my question mark has to be 180. So what does my question mark equal? 110 degrees. Now, the bottom right one is a little more difficult, only because it involves solving for x and then solving for the degrees. So, I have 80 plus 11x minus 10 equals 180. So let's combine our like terms. So I have 11x plus 70 equals 180, which means that I eventually have, I'm going to subtract 70, I get 110 equals 11x. I divide, I get x equals 10, which means that this side is 80, and when I plug this in, I get 110 minus 10, which makes this 100 degrees. Let's keep going. Let's do these ones. This one says I've got opposite, I'm looking at opposite sides. Which property involved opposite sides? Should be property 2. Property 2 says that opposite sides are the same. So that means that if this side is 12.6, what is this side? Also 12.6. That means that this 2x plus 15 equals x plus 15. So if 2x plus 15 equals x plus 15, and I solve, what do I get? Subtract 15 on both sides, so I get 2x equals x. Then I subtract this guy over, I get x equals 0. So both sides are a length of 15. Okay, part B is a little harder. Okay, so the first step again is going to be to plot my parallelogram. So I'm going to draw my plot. Plot J, K, L, and M. And I'll connect my lines. Okay, so using the distance formula, I need to show that these opposite lengths are equal. So I need to show that JK is equal to LM, and I need to show that KL is equal to JM. So let's do JK first. All right, my distance, I need to do x2 minus x1. So I'm going to get 1 minus 0 squared plus 5 minus 0 squared. And I get that to be 1 squared is 1, plus 5 squared is 25. So I get the square root of 26. Okay, now let's do LM. I'll do it next to it just so you can see it. LM, x2 minus x1. It's going to be 3 minus 4 squared plus y2 minus y1. 0 minus 6 squared. That gets me my distance to be the square root of -1 squared, which is 1, plus -6 squared, which is 36. So that becomes 37. All right, the square root of 26 does not equal the square root of 37. So we know that this is not true. So already we've shown that it's not going to form a parallelogram. All right, but just for fun, let's do in this blank, let's do KL, and then we'll do JM, just to double check ourselves. On the right, we're doing KL and JM. So I'm going to do distance equals the square root of x2, 4, minus 1 squared, plus y2 minus y1 squared. And I end up getting 4 minus 1 is 3, squared is 9, plus 6 minus 5, which is 1, squared, which is 1. So I get the square root of 10. JM, I do x2 minus x1, so I get this d equals square root 3 minus 0 squared plus 0 minus 0 squared. So I get the square root of 9, which is actually 3. And we know that the square root of 10 and the square root of 9 are not equal. So again, we know that this does not form a parallelogram. Okay, so the last example is on the right. Right? It involves the midpoint and diagonals that bisect each other. So what property is that? Should be property 5. Okay? So that means that if RT is 19.8, we need to find this whole distance. So property 5 says that they bisect each other, which means that this length equals this length. So because we know that RT equals 19.8, we also know that TP equals 19.8. So that means that RP is equal to 19.8 plus 19.8, which is 39.6. All right, the next one is slightly harder. It involves the midpoint formula, so keep that midpoint formula open and ready. It says use the midpoint formula to determine whether the given vertices form a parallelogram. So again, step 1, graph your points. -2 up to P. 1, 8. I guess I should have left more room here. It's Q. R is 4 and 5. S is 3, -2. All right, and then I'm going to connect all my points here. All right, so using property 5, we need to show that my diagonals bisect each other at this midpoint. So if we can prove that the midpoint of Q and S is the same point as P and R, then we're good. So we're going to find the midpoint of Q and R. I'm sorry, Q and S, and then we'll go down and we'll find the midpoint of P and R. So, Q and S, I need to find the midpoint, and let's write the midpoint formula up here just so we have it available. It should be x1 plus x2 over 2. y1 plus y2 over 2. All right, so if I add up my Q and my S, x1, x2, 4. So I get 1 plus 3 over 2. And then I add up my y's, 8 minus 2, or 8 plus -2 over 2. That gets me a midpoint of 2, 3. All right, now let's find the midpoint of P and R. So if I find the midpoint of P and R, I'm going to add up 4 and -2, so 4 plus -2 over 2, and 2 plus 5 over 2. And I get put arrows here. I get 2 over 2, which is 1, and then I get 7 over 2. All right? So since those are not equal to one another, this is not a parallelogram. So you now have all of these problems done. They should all be completed and in your notes. So now you can get started on the worksheet, and of course I will be available for questions should you have them.